Hello everyone. Today I will show you some experiments of light. You see, we have our this is a laser light, and we will show you some lens in which you can see the converging and diverging properties of lenses. Here you see that we have one lens. This lens, you see, this is a convex lens, or you can say it as double convex lens. We'll show you how the light converging to a point with this laser light, right? You see here that the light will be converging. You see here. If you switch off the light, you'll see the light is converging to a point. Let's see how it is converging. This is convex lens, and convex lens converging the parallel lights to a particular point, and that point is called our focus. Let us see how it converging the laser light. Now see how the light is converging with this convex lens. This is the convex lens, and let us find that the light is converging. You see, you can see the light in this dark, that is ray of light. You see this ray of light, and if you put this on lens, you see the light is converging to a point. You can see in this way that if you see the light focusing here, you see this light is focusing here. You can see the ray of light. This is a laser light, and if you put this convex lens, you see the light is converging to a point, that is focus. See here, the light is converging, and this convex lens converges the light to a point, and that point is known as our focus. You see here, you can see the ray of light. It travels in a straight line because it is a monochromatic light. You see, you can see the ray of light. Here you see, this is our ray of light, and I put this is our ray of light, and if we put this lens, convex lens, you see there is a converging property of this lens. The light is converging. You see, you can see the ray of light. See, you can see this light is converging to a certain point. That's why you call this lens as convex lens. Because convex lens has the property to converge the state of parallel lines to a certain point, and that point is called our focus. You see, you see this ray of light. It travels in a straight line. You see, this line is straight lines. And from this experiment, you can see also that light travels in a straight line, right? Not only that, if we put this lens, convex lens, it will see the light converges to a point. We can show you in a better way, in this way, that as you see, this is the straight line we are getting, but if you put this lens, it is converging to a point. You see here, this is the direction is changing, right? Here you see, this is in straight line. If you put the lens in between, then it is converging to a certain point. You see, it is converging. That means if we put two parallel rays of light, then it will converge to a point, and that is our focus. That is our focus. You see here, right? Now you see that with this lens we have found that this is a converging lens, and it has the property to converge two or three parallel lines into a certain point. So this is also called a converging lens also, right? This lens is also called a converging lens, right? Now let us switch on the light so that we can explain it in a better way. Now also you can see in this light that this is our convex lens, and I put a this light, you see that this is converging, this is a converging lens. Because here if you see, I see that this is our convex lens, and we put on the light, you see the light is going in this direction straight, but you put this lens in between, it is converging this light. You see here, the light is converging, right? This point, this is the initial point. If you put this lens, it is converging the point. See here, it is converging, and you can see this straight line in this smoke also, right? Here you see, this is the straight line. If you put this lens, convex lens, in the path of the ray of light, it converges, it goes down. You see here, it goes little bit, goes down. That means it is converging to a point, right? Then if we give two parallel rays of light, then it will converge to a point, and that point is known as the focus of the point. Here you see, it is converging, right? Now if you take another lens, this lens, what type of lens it is? It is a concave lens. And if you see in concave lens, you see the ray of light is here, right? If you see, put this lens in between the ray of light, it is diverging the rays of light. You see, it goes up. You see, this is the original position, this is the original position, and if you put the lens in between, you see it is diverging, it is going up, right? It is going up. You see here, this is the original position. When we give this, it going up, You see, suppose this is the original position, this is the original position. If you give this lens in between the ray of light, it goes up. See here, it goes up. That means it is diverging. The line is diverging actually. You see here, this is the original ray of light. This is the original point, right? If you put this lens, you see here that the light goes up. That means it is a diverging lens. Therefore, this concave lens acts as a diverging lens, and this convex lens, this convex lens acts as a converging lens. You see, it goes downward, right? You see here, this is our position. If we put this one, you see it comes down, that it is converging the rays of light. You see here, yes, see here, it is converging the point, right? Now, if we switch off the light, and you see that it can be seen also in a better way. Here you see, this is our ray of light. You see, you can see the ray of light through this space, right? This is the original position, and we are putting the this. You see, this is the point, right? And I put this convex lens. It is converging the point, right? You see here is the original position, right? It comes down. That is, it is converging, right? Therefore, this lens is a converging lens, right? Therefore, we can say that convex lens is our converging lens. See here, you can see the rays of light here. If we put this lens, you see the light is converging to a certain point. If we give two parallel lines, that will converge to a point, and that point is our focus, right? And the focal length of this lens is actually 20 centimeters, right? Let us switch on the light, and now if we take the concave lens, let's see what happens. This is our concave lens. You see here, this is our concave lens. You see, and let's see if we put concave lens, what happens to the light. You see here, let's see. You see, this is the ray of light, right? And we put the concave lens, you see the light is diverging. You see this point, if it put, it goes up. You see here, goes up. That means this light is diverging with this lens. Therefore, this concave lens is also known as divergence lens, and convex lens is also known as converging lens. Because when a parallel ray of light goes through the convex lens, it all the parallels converges to a point, and that point is our focus. And here you see, this is our lens, this is our concave lens, and concave lens is diverging the light. That means it appears to meet at a certain point, and that is our focus, right? You see here. Now I'll show you the light, how the light goes in a prism. Let's switch on the light, and I'll show you the effect of laser on prism. Now see, this is our prism. You see here, this is our prism, right? And we show you that the ray of light is bending towards the base of this prism. You see, and the angle of this prism is 60 degree because this is an equilateral triangle, right? Let us see how the light goes in this way. You see here, if we you see if we give this light, you see the ray of light is bending towards the towards the base of the prism. Let's see, if I if we if we switch off the light, you see that the rays of light is bending towards the normal of the towards the base of the prism, right? See, this is the prism, right? Now let's see what happens if I give a ray of light. Here you see the rays of light is bending towards the normal and there is an angle of deviation. See here, you can see the rays of light in a better way. See, right? And you see, this is our prism, and if you put the see this ray of light, here the rays of light is this is the incident ray and the rays of light is bending towards the normal, and you can see the angle of deviation. Later on I will show you the angle of deviation in this prism, right? You see here that the rays of light, the incident ray is bending towards the normal of the prism. After that it is coming out and we found there is an angle of deviation. Later on we will find the angle of deviation also, right? You see, this is our prism, and if you see very clearly that this ray of light, see this ray of light is bending towards the base of the prism and it deviates, and there is an angle of prism, there is a deviation in the light, and that angle is known as angle of deviation. Later on we will find how to find the angle of deviation with this prism, right? Here you see, when you put the light on the prism, it deviates, right? And you can find the angle of deviation of this light, angle of deviation of prism with this experiment. You see how the light is diverging. Now, dear friends, now I'll show you the glass prism. This is our glass prism. You see, this is the glass prism, and I'll show you how the light is refracting in the surface. You see here, this is our refracting surface. If we take this glass and let us give the light, let's see how it reflects. You can see here that the light is refracting in the surface. See here. With this glass slab, you see the light is refracting through this glass slab, and there is a bending of light. And in this glass slab, you see that you see here, we are getting the lights. To the glass slab, the light is reflecting, and you can find also in this method the refractive index of this glass also. Right? You see here? In this way, you can find the refractive index of the glass also. Right? Now, I will show you some experiments with mirror. Right? Let us find the mirror. You see the reflection through the glass slab. You see, this is the glass slab. Here you can see the ray of light reflecting through the glass surface. You see here, you can see the rays of light also. Here you see how the ray of light is reflecting through this glass slab, and you can find the refractive index of this glass slab also with the help of reflection through laser light. Now I will show you some mirrors and see how the laser is reflecting through the mirrors. Right? Let us take some mirrors. Here you see, I have taken a concave mirror, right? This is a concave mirror, right? And you see how the mirror is reflecting this light. This is a concave mirror. See how the rays of light is reflecting. You see here, here you see how the rays of light is reflecting. You can see, you can see the incident ray and also the reflected ray. You see here. You see, this is one is incident ray, another is reflected ray. You see here, and this is our concave lens. You see how the light is, one is incident ray, another light is reflecting reflection light of reflected ray. One is incident ray, another is reflected ray. I will show you another mirror, and you see here we will show you another mirror, and this mirror is a convex mirror. This is a convex mirror. You see, this is a convex mirror, and see how it reflects the light. Now see how this convex mirror is reflecting the light. You see here. Here also you can see the incident ray and the reflected ray. You see here. You can see the incident. If you increase the incident ray, angle of incidence, then the angle of reflection is also increasing. You see here. Right? Now I will show you how the incident ray and reflected ray. We know that in a mirror, in a plane mirror, the angle of incidence and the angle of reflection is same. Here you see, this is a convex convex mirror, and in convex mirror we know that there is a wide field of view, wide field of rear view, right? I will show you another mirror, that is plane mirror, right? You see here, this is our plane mirror. This is a plane mirror, right? Now see how it reflects the light. I see how the light is reflecting in this. You can see the incident ray and reflected ray also. You see here, you can see the incident ray and reflected light. This is the incident ray and this is the reflected ray. Now, if we take two or three mirrors at the same time and see that there is a pattern of light. You see here, if you see, if you take two or three mirrors at the same time, you'll see the pattern of light. You can see here in the incident ray and the reflected ray in all the three mirrors. You see here, the pattern is changing also, right? In this way, you can see various patterns with the help of these mirrors, with the help of this light. You see, you see how the light is reflecting. I see the laser light goes far away from one place to another. You see here, this is our light, and you see these are the different types of mirrors. One is plane mirror, one is concave mirror, and one is convex mirror. Right? How you see how there is a difference in the reflection of all the mirrors. One is plane mirror, and there are two spherical mirror. One is concave mirror, and one is convex mirror. Right? Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.